Hello everybody, I'm Abasud and welcome to my course on Nist ICS security, that is Industrial Control System Security. And today we are going to discuss about two things, that is DCS, that is Distributed Control System, and PLC, that is Programmable Logical Control. So let's start with this. DCS are used to control production system within the same geographical location for industries such as oil refineries, water and waste distribution treatment, electrical power generation plants, chemical manufacturing plants, automotive production, and pharmaceutical facilities. These systems are usually process control or discrete part control systems. So TCS are integrated as a control architecture containing an supervisory level of control overseeing integrated subsystem that are responsible for controlling the details of a localized process. A DCS uses a centralized supervisory control loop to mediate a group of localized controllers that share the overall task of carrying out an entire production processes. Product and process controls are usually achieved by developing feedback or fed forward control loops whereby key product and process conditions are automatically maintained around a desired set point to accomplish the desired product, and for process tolerance around a specific set point, which is specific process control. Or more reliable PLCs are employed in the field and are tuned to provide the desired tolerance as well as the rate of self correction during process upsets. By modularizing the production system, a DCS reduce the impact of single fault on the overall system in many modern systems, and the DCS is interfaced with the corporate network to give business operators a view of production. So now let look into an example. DCS encompasses an entire facility from a bottom level production process up to the corporate or enterprise layer. In this example, the supervisory controller, that is control server, communicate to the subordinate via control network. The supervisor sends set point to and requests data from distributed field controllers, and the distributed controllers control their process actuators based on control server commands and sensor feedback from process sensors. The field control devices shows include a PLC, a process controller, a single loop controller, and a machine controller. The single loop controller interface sensors and actuators using point to point wiring, while the other three field devices incorporate field bus network to interface with process sensor and actuators. Field bus network eliminate the need for point-to-point wiring between a controller and an individual field sensor and actuator. Additionally, a field bus allow greater functionality beyond control, including field device diagnostics, and can accomplish control algorithm within the field bus, thereby avoiding signal routing back to the PLC for every control operations. Standard industry communication protocol designed by industry groups such as Modbus and Fieldbus are often used on control network and Fieldbus networks. In addition to the supervisory level and the field level control loops, intermediate level of control may also exist. For example, in case of DCS controller, a discrete part manufacturing facility, there could be an intermediate level supervisor for each cell within the plant. This supervisor would encompass a manufacturing cell containing a machine controller, that processes a part, and a robot controller that handles raw stock and final products. There could be several of these cells that manage field level controllers under the main DSC supervisory control loop. So this is what we are having for a DCS, that is a distributed control system. Now if we look again for a second thing, that is PLC, that is programmable logic controller. So PLCs are used in both SCADA and DCS system as a control component of an overall hierarchy system to provide local management of processes through feedback control as described in section above. In area of SCADA system, they may provide the same functionality of RTU. When used in DSC, PLCs are implemented as local controller within supervisory control scheme. In addition to PLC used in SCADA and DLC, PLCs are also implemented as a primary controller in a smaller control system configuration to provide operational control on of discrete processes such as automobile assembly lines, power plant, suit blowers control. These topologies differ from SCADA and PLC in that ways generally lack a central control servers and HMIs, and therefore primarily provide closed loop control without direct human involvement. PLCs have a user programmable memory for storing instructions for the purpose of implementing specific functions such as IO controls, that is input output control, logic, timing, counting, three mode proportional integration, integral derivative, that is PID control, communication, arithmetic, and data and file processing. A manufacturing process being is performed by a PLC over a field bus network. The PLC is accessible via a programming interface located on a engineering workstation, and data is stored in data historian and all connected to a LAN. So this is what we are having today for in DCS and PLC topic. Thank you for joining.